Automatic, Addison.
In this tutorial, we will explore how to use the standard template library in C++. Let's explore how to use double-ended queues or Deques in C++. These are used for managing sensor data streams and other robotics applications. Deques are particularly useful when you need to process data from both ends of a collection efficiently. So we have VS Code open, and let's create a new file called sensordatahandling.cpp. And as always, we will start by writing our pound includes. Int main. Okay, and std_dec float sensor data. So we're going to simulate a stream of sensor data, and let's add new readings at the back. So sensor data dot push back, and let's just add 2.5 semicolon, and let's copy that 2 more times. 3.1 and 4.7. Okay, you could put any numbers you want. I just chose those. And let's do std_cout processing sensor reading. And let's process the reading at the front, sensor data dot front std end L. And after we do that, let's remove it from the front. Dot pop front. All right, yep, all good. And now let's add some more readings. Sensor data dot push back. Let's do 5.5. Sensor data dot push back. And let's do 6.8. Okay, and let's process another reading. std_cout processing sensor reading. Sensor data dot front std end L. So sensor data dot pop front. Now let's display the remaining data. So std_cout remaining sensor data. Excuse me. All right, let's do float reading sensor data. We'll do std_cout reading. And let's do std_cout std end L. And as always, we'll do return 0. So that is our code. Let's walk through it after we run it. Okay, and so here we just ran the code. You see our readings down here, and let's just talk a little bit about it. So we are simulating a stream of sensor data. Here we're adding new readings at the back. Here we're processing a sensor reading, the reading at the front, okay? And then we remove it, and then we're pushing some more readings into this deck, double-ended queue. And then we're processing another reading, and then we display the remaining data down in here. And I ran it, and you can see we have 2.5, 3.1, and these numbers down here. So you should see how the sensor readings are processed and the status of the queue is after each operation. So this example demonstrates how Deques can be effectively used in robotics to handle data streams where the newest data might need immediate processing and older data needs to be cleared after handling. This is important for maintaining real-time performance in systems like autonomous vehicles or robotic sensors. Okay, let's close this file. And now let's explore how to employ iterators in C++. So iterators provide a flexible way to traverse and manipulate elements in containers, such as vectors and arrays, which are commonly used in robotics to store and process data. Let's create a new file called iterator example.cpp. Iterator example.cpp. And let's do a basic example. Start with our pound includes IO stream and pound include vector. And let's do int main. Do std vector int sensor data. We'll do 10, 20, 30, 40, 50. All right, let's do for loop for auto t equals sensor data dot begin it not equal, okay, sensor data dot end plus plus it. Okay, and then in here, we're going to do std cout asterisk it so std cout std indel. Okay, so what did we just do there? We are using iterators to traverse and print the vector. So that's what's going on in here. Next, let's use iterators to modify elements in the vector. So let's do for auto it equals sensor data dot begin. It not equal sensor data dot end plus plus it. And in here, we're going to do asterisk it asterisk equal to. And now let's print the modified vector. So for const auto value sensor data. Do std cout value okay. So std cout std indel return 0. Save. In this code, we include the necessary headers, IO stream for input-output operations, and vector for the vector container. In the main function, we create a vector named sensor data to represent a collection of sensor readings. We initialize it with some sample values. We use iterators to traverse and print the elements of the vector. we create an iterator, IT, and initialize it to sensor data begin, which points to the first element. We iterate until it reaches sensor data end, which is the position after the last element. Now, inside the loop, we dereference the iterator using asterisks right here, and then IT, and that enables it to access the value at the current position and print it. Next, we use iterators to modify the elements in the vector, okay? And we create another iterator, an iterate over the vector as before. This time we dereference the iterator and multiply the value by 2. And that effectively doubles each element. Finally, we print the modified vector using a range-based for loop, which automatically uses iterators under the hood to traverse the vector. Now we run the code. So you can see the original vector printed, followed by the modified vector with each element doubled. Let's explore how to work with Deques, lists, and forward lists in C++. These container types offer different characteristics and are useful in various scenarios when dealing with robotic data and algorithms. So let's begin by creating let's open that again. Okay, by creating a piece of code called containerexample.cpp. Okay, and let's start off by doing our pound includes. Int main. And let's start by working with Deques. Robot positions is equal to 10, 20, 30. Let's do robot positions dot push front 5. Robot positions dot push back 40. Stood, C out, deck. And let's do 4. Const auto pose robot positions. We do stood, C out, pause. Okay. And now over here, we're going to do stood, C out, pause. Okay, everything looking good so far. And sorry, it's been a long day. Let's do this, stood, and L. Okay, that looks good. Automatic pilot here. Okay, so that's working with Deques. And now let's go on to list. So we're going to do over here, we're going to do stood, list, stood, string, robot actions. And let's create a list of actions. How about we move? What's another good one? Let's think. What's another good one? How about rotate? And what about we scan? Another good robotic action. Okay, that's our list of actions. And now let's do robot actions dot push back And let's add another one, grasp. And another one, dot pushback, initialize. Okay, let's do stood, cout, list. And let's do a for loop for const auto action robot actions. And we'll do stood cout action. Down here, we'll do stood cout stood inline. Okay, that's lists. And now let's work with forward lists. Stood forward list, forward underscore list, double. Let's do sensor readings. 1.5. Okay, let's add 2.7. You can add any number here. Okay. And let's do sensor readings. Let's do push front 0.8. And let's do stood cout forward list. And we'll do for const auto reading sensor readings. Let's do stood cout reading. Down here we do stood cout stood indel. Return 0 down here. Whew, that is a lot of code. So what are we doing here? So in this code, we start by including the necessary headers, IO stream for input-output operations, Deque for the Deque container, double-ended queue, list for the list container, and then forward list for the forward list container. So in the main function right here, we demonstrate working with each container type. So let's talk about Deque. Here we create a Deque named robot positions to store integer positions. We use push front to add an element at the front and push back to add an element at the back. We then print the contents of the Deque using a range-based for loop. Let's go on to list. So we create a list named robot actions to store string actions. We use pushback to add an element at the back and push front to add an element at the front. We print the contents of the list using a range-based for loop. So with forward list, we create a forward list named sensor readings to store double readings. We use push front right there to add an element at the front. We print the contents of the forward list using a range-based for loop. And when we run the code, let's see what it looks like. So here, you can see we had 10, 20, and 30 right there, but because it's a double-ended queue, we could add elements at the front, like the 5, and then we have the 40, which we added at the end. Now with our list, we have move, rotate. Oh, I called it scam. Let's scan. Let's run that again. Move, rotate, scan in the middle there. And we then added, in the front there, and then we added grasp at the end, and then initialize at the end. That's a normal list. Just added it there. Put by pushing back. And we iterated through it and printed out the elements. And here's our forward list. We had 1.5, 2.7, and 3.2, and we added 0.8 at the front of our forward list. So Deques allow efficient insertion and deletion at both ends. Lists provide constant time insertion and deletion anywhere in the container. And forward lists offer a singly linked list with efficient insertion and deletion at the front for forward list. Let's explore how to handle sets and multisets in C++. Sets and multisets are associative containers that store unique and duplicate elements respectively, and they can be useful for managing distinct or repeated data in robotics systems. So sets and multisets. Let's get started by creating a program called setExample.cpp. setExample.cpp. And let's type this into the code editor. Pound include iostream, pound include set. Let's do int main. Let's do stud set int unique landmarks 10, 20, 30, 40, and let's just do 30. Okay. And let's add a 20 in here. Semicolon to close it out. So unique landmarks is our set. And let's do a stud cout unique landmarks. And we'll do a for loop for const auto landmark unique landmarks. Stud cout landmark. Stud cout stud indel. Create some more space. So that's our sets. And now let's do multiset. Multiset stud string repeated commands equal. And let's do move, rotate, scan, move, grasp. And let's put a semicolon at the end here. Now let's do stud cout repeated commands. And we'll do for const auto command repeated commands. And we'll do stud cout command. Do stud. Let's get rid of this here. We need to close that out here. Okay. Cout and then stud indel. Everything looking good? Okay, so in this code, we include the necessary headers, iostream for input, output operations, and set for the set and multiset containers. In the main function, we demonstrate handling sets and multisets. We create a set named unique landmarks, okay, to store unique integer landmarks right here. We initialize it with some values, including duplicates, and the set automatically removes the duplicate elements and stores only the unique values. So you can see we have our duplicates right here, 20 and 20, and 30 and 30. And a set will actually remove the duplicate elements and just store the unique values in here. And then we print the contents of the set using a range-based for loop. We then create a multiset named repeated commands. This stores repeated string commands. We initialize it with some values, including duplicates. The multiset allows duplicate elements and stores all the occurrences. We then print the contents of the multiset using a range-based for loop. Now let's run the code. You can see how the duplicates 20 and 20 and 30 and 30 were removed in the set. And you can see the repeated commands right here in the multiset. So sets are useful when you need to store and efficiently retrieve unique elements such as distinct landmarks or sensor readings. Multisets, on the other hand, allow you to store and manage duplicate elements, which can be helpful for tracking repeated commands or measurements in robotic systems. Now let's explore how to use Map and Multimap in C++ for robotics applications. Map and Multimap are associative containers that store key value pairs. It allows for efficient lookup and retrieval of values based on their associated keys. So let's create a new file called mapexample.cpp. And let's type the following into the code editor. #include iostream, #include map, #include string, int main, and we'll do stood map, stood string, int sensor readings. We'll do sensor readings. Let's add the first one. Let's say temperature equals 25. Temperature equals 25. Sensor readings. Humidity equals 60. Pressure equals 10, 13. Now let's do for const auto. So a range-based for loop again to iterate through all the sensor readings. So stood cout reading.first. Reading dot second stood end L. Does everything look good? Yes. Now let's do a multi-map. So we're going to do stood multi-map, stood string, robot command. Okay, and Now let's add some stuff here. Robot commands dot insert. Insert's how we do it. Curly braces, move, forward. And I'm going to copy this 3 more times. 2, 2, 3, and let's do move, and let's do backward. Left. Rotate. Rotate. Right. Okay, and now let's do another for loop. For const auto command robot commands stood see out command dot first command dot second stood end L. So looking okay. Everything looking good. Okay, so in this code, as usual, we include the necessary headers. In the main function right here, we demonstrate the usage of map. We create a map named sensor readings that associates sensor names, which are keys, with their corresponding values. We insert key value pairs into the map using the bracket operator. We then iterate over the map using a range-based for loop and print each key value pair. Next, we demonstrate the usage of multimap. We create a multimap named robot commands that associates command types with the keys with their corresponding parameters values. We insert key value pairs into the multimap using the insert function. Multimap allows duplicate keys so we can have multiple entries with the same command. We iterate over the multimap using a range-based for loop and print each key value pair. Now we run the code. And there you go. Humidity, pressure, temperature. You can see all the sensor readings and the robot commands printed in the terminal, and this demonstrates the usage of map and multimap. Map is useful when you need to associate unique keys with their corresponding values, such as storing sensor readings or configuration parameters. Multimap allows duplicate keys and is helpful when you need to store multiple keys for the same key, such as mapping command types to their parameters. Okay, for your computer science majors out here, let's take a look how to manipulate stacks in queues. You probably remember that from your class in your coursework. So let's take a look at how we can manipulate stacks and queues in the context of a robotics application. So these are very important data structures. So I'm going to create a new file called stackqueueexample.cpp. Do our pound include iostream, pound include stack, pound include queue. So int main. Okay, here's our stack example. So stood stack int my stack and my stack dot push of 10. Okay, and let's just copy that 2 more times. 20, 30. So under here, let's do stood see out top element of the stack. Okay. And let's do my stack dot top. And then do stood end L. Okay, top element of this stack, and then we want to remove the top element of the stack by using the pop method. Okay, and let's do stood cout updated top element. My stack dot top. Stood end L. Okay, now let's go to our queue example. We're going to go stood queue stood string my queue. Now let's go to my queue dot push to add to the queue, and we're going to say sensor data. Let's do my queue dot push. We'll do robot command and do my queue dot push. We'll do navigation goal. So stood cout front element of the queue and let's get it now. My queue dot front stood end L. Let's do my queue dot pop. And let's do stood cout updated front element. My queue dot front. Stood end L. Then we do return 0. Okay, so we got all our code down. So what did we do here? So first we created our stack called my stack to store integers. We pushed the values 10, 20, and 30 onto the stack using the push method right here. We then print the top element of the stack using the top method, which returns 30. Okay, next we remove the top element from the stack using the pop method. Finally, we print the updated top element, which is now 20. Okay, and so for the queue example, we create a queue my queue to store strings right here. We add the string sensor data, robot command, and navigation goal using the push method. We then print the front element of the queue using the front method, which returns sensor data. Next, we dequeue the front element using the pop method. Finally, we print the updated front element, which is now robot command. So let's run the code. So here you can see here, top element of the stack, 30, updated top element, front element of the queue, sensor data, and then robot command. So you can see the top and front elements of the stack and queue, respectively, printed in the terminal. Let's explore how priority queues can be utilized in C++ to manage robotic tasks efficiently. Priority queues are particularly useful in robotics for scheduling tasks based on their priority level, ensuring that critical operations like obstacle avoidance or emergency stops are handled first. Let's begin by creating a new C++ file named robotic task priority queue.cpp. Robotic task priority queue.cpp. So here's our code. And let's do pound include IOStream, pound include queue, pound include vector, pound include function, functional actually. This is for something we're going to use later. Let's do struct task, say int priority, okay, and then stood string description. Okay, let's do bool operator. I'll explain this in a second. Const task other const return priority. This is an example of operator overloading, which we discussed in a previous tutorial. So higher numbers mean higher priority. Let's close it out. Semicolon. Now the main function. And let's create a priority queue to manage the tasks. So we're going to do stood priority queue, and then we're going to do tasks, and let's insert our tasks. To navigate to charging station. Tasks.push. 1, highest priority. Sorry, I mean lowest priority. Send sensor data. And then new tasks push. And what's another task? How about emergency stop? Okay, and then put a semicolon here. So now what we want to do is now that we have our priorities for each tasks, with higher priorities being like emergency stop and lowest being send sensor data with the 1, we need to execute tasks based on priority. So to do that, we're going to go here and let's do a while loop. While not tasks.empty. And let's do task equal tasks.top. And let's do tasks.pop. Let's do stood cout executing task.description. Stood end L. Go down here and we'll do turn 0. So in this code, we define a task struct with the priority and the description. We overload this operator right here, less than operator, to compare tasks based on their priority. We then create a priority queue that holds tasks and inserts 3 sample tasks right here. We then simulate the execution of tasks down here in the while loop with the emergency task, emergency stop right here taking precedence. So when we run the code, You can see emergency stop was first, then navigate to charging station, which had the 2, and then the lowest priority, which is send sensor data, which is the 1. So you can see how the tasks were executed in the order of their priority, with the emergency stop being handled first. So that's it for this tutorial. Thank you for watching, and keep building.